Alright, so guys, today, no, you all set? Today and tomorrow are the last two sections of new stuff for the week. Right? 3.2 is split into two sections. We'll do part 1 today, do part 2 tomorrow. Alright, and then obviously we'll quiz on Thursday. So again, we're still going to be talking about functions, but now we're looking at a specific type of function. Alright, we're going to look at that today. Let's see what we got here. Alright, so a linear equation in two variables, x and y, is an equation that can be written in the form of what? So what form do we use? We probably used it last year, other times in middle school. What's that linear equation that we use? You see it all the time. Like if you want to graph something. Exactly. Alright, so on your notes, you already have a linear equation in two variables. So for that's going to be what we're going to use. Y equals mx plus b. Now we're not really going to get into how we graph a linear equation. Not going to do anything like that today. Like, okay, start at the y-intercept, We're not going to do that today. Alright? Now, we have lines coming out of two letters there. What's one letter that we have a line coming out of? Joe? No. But we do have a letter coming out of M, I agree. Alright? Paige, what other letter do we have a line coming out of? B. That means those two things, B and M, they mean something. Alright? They represent something in that equation, the B and the M. Does anybody know what they represent? The M and the B? Market basket. No, not market basket. Alright, so the B is going to be the y-intercept, and then the M is going to be the slope. Has people seen this before? No. Slope-intercept form, y equals mx plus b. I'm sure most of you guys probably have. Alright, again, we're not going to get like super into like how you graph those, like how you graph a linear equation. We just want to show you that this is what it looks like. You have to have an you have to have a y, an x, and then two other numbers, usually. Like something like this, y equals 3x plus 2. That's an example of a linear equation with two variables. I have the y, I have the x. Okay? And again, it's not super important that you know, like, we're not going to ask you to identify the slope. We're not going to ask you guys to, like, say what the y-intercept is. We just want you to have a basic understanding of what that equation looks like. All right? What the linear equation looks like. Now, very important thing, you have the two little dashes on there. Most important thing about a linear equation, because we're going to ask you, just like we did with identifying if it's a function or not, like we did in the warm-up, all those different examples with the coordinates, the chart, the graph, right? We're going to ask you to identify a couple different ways whether it's a linear function or not. If we're looking at it in a graph, the graph is going to be a straight line. Not going to be no curves in it, no corners, right? It's going to be a straight line. No circles, nothing like that. It's going to be a straight line. So that's one way to identify. We'll give you a graph and we'll say, is it a linear function or not linear? Look at the graph. It's a straight line. Yes, it's linear. If it's got curves in it, if it's like has an angle in it, it's going to be non-linear. All right? Now, you have the little dot below there. A linear function is a function whose graph is a non-vertical line. So any straight line, this is a big thing that confuses people. Any straight line that is not vertical. It cannot be vertical. So if I had a vertical line like this, up and down, that means it's going to be non-linear. Vertical lines are non-linear. That's one big thing. We might give you a graph like that in a test, just to try to trick you guys. If it's vertical, it's non-linear. Give me any straight line that's what this means. Any straight line that's non-vertical or not vertical.
So horizontal?
Horizontal's or this is okay?
So
This is okay?
My life rides horizontal.
This is okay? Anything like that is fine. Alright? How about this?
no, that's not.
That's nonlinear, right? It's not, yeah, it has two straight lines, but it's got that curve in the middle. This,
Where do you see graph?
nonlinear. This, nonlinear. All those things are nonlinear. Alright? It has to be a straight line that's not vertical.
So,
Alright?
the
What's
first
up,
one,
Alan?
right?
Huh?
It's supposed to be not that one.
That is nonlinear. How about this?
That's linear.
Linear? How about this, Connor? Linear or nonlinear?
Linear.
How about this?
Non-linear.
No, it's still straight, right? It's gonna be a straight line that's not vertical. Alright? Non-linear, non-linear, non-linear. They're all not straight. Huh?
It's not a straight line, it's a straight.
Yeah, that's what I'm saying. Non-linear. It's not linear. Alright? Alright? Another thing we have to understand about a linear function, or linear, it has a constant rate of change. Right? That means that, like we told a couple of weeks, we'll talk about slope. That slope is going to be the same. Right? It's not going to change. Like for this one, it could be like slope could be 2, right? Like I'm going down 2 over 1, down 2 over 1, down 2 over 1. It has that same like angle the whole way through. Right? It doesn't change. That's why something like that snake doesn't count. It doesn't work. It's not linear. It's not constant. It's not the same. It's not that same. It's not the same. Like we talked about. So that last bullet on the top part there, a nonlinear function is the exact opposite. Right? It does not have a constant slope, and therefore the graph is not a line. So big thing you gotta understand between linear and nonlinear. Linear, straight line, as long as it's not vertical. Nonlinear is anything else. Squiggly, a circle, whatever. Anything that's not straight. So remember, nonlinear also includes something that's vertical. A vertical line is nonlinear. Alright? So now, we'll take a look at some examples, guys. Example 1. Guys, on your notes, I know these aren't drawn there. They don't have to be perfect. Alright, doesn't have to be exact. Right? This one's like 1, 2, 3, 4, 5.5 to the left, 5.5 to the right. It doesn't have to be exact. Just estimate. Alright, even if it's a little bit more narrow or a little bit wider, that's okay. As long as it's somewhat of a U shape, that's the most important thing. As long as you doesn't have to be exact. The big thing here, I want you to understand the difference between linear and nonlinear. Right, that's the most important thing. Alright, so this one says, example 1. Does this graph represent linear or nonlinear? What do you think, Will, for this one? A, is it linear or nonlinear?
It's linear.
It's linear. Again, someone remind me, when something's linear, what should it look like, Joe?
Straight
A straight horizontal or diagonal line. So rethink that.
Non-linear.
It's going to be non-linear, right? So it's got the curve to it. So this will be non-linear because it's not straight. That's what linear means, right? A line. That's not. It's a line, but it's not straight. Usually we think of a line as something that's straight. That's not straight. That's why it's non-linear. All right. So A is going to be non-linear. Oops, I'm going to destroy it. Okay, B. Z. What do you think? Is B going to be linear or non-linear? Yeah, right? It's a straight line. It's going diagonal. It's not vertical. I'm fine. Oops, I put line. That's going to be linear. It's a straight line. It's diagonal, right? That's it. Again, this is a simple. It's all. When we ask you a question like this on the test, that's all we're looking for. Look at the picture. Is it a straight line? Great. It's not vertical. It's linear. If it's vertical or squiggly or has, comes to an angle, it's going to be non-linear. That's all we're looking for when we're doing these. Nothing more than that. C. Linear or nonlinear? What do you think, Noah? Linear or nonlinear? That's linear, right? We're trying to trick you, right? That's a horizontal line. If it's horizontal, it's fine. What if it was vertical? Up and down? Non-linear, right? Up and down, no, right? Up and down is a no, across is okay.
I thought up and down was okay for linear.
Huh? No, that means vertical.
Joe,
Oh, then it's vertical.
a vertical line, Joe, is linear,
Oh, yeah.
but it's not a function. So even though a vertical line is linear, it's not a function. The question was, are these linear functions?
Yes.
So you're
So this is, like Mr. Hager just said, this is a linear function. It's okay, all right? Let's look at D. Is D a linear function? Yes or no? Paige?
Non-linear.
Non-linear, right? It's going to be a non-linear function. Why, Paige?
Because it's not a straight line.
Yeah, it's on a straight line, right? It looks like a V, right? So we don't want that, right? That's going to be a non-linear function. So that's one way we'll talk about. One way we'll look at to determine whether something's a non-linear function or a linear function, just based on the graph. I think we're going to look at two other ways to determine whether it's a linear function or a non-linear function. All right, Fred, you with me back there? Sure? All right. So again, that's one way we're going to look at it. Now, we're going to look at, this is what Will talked about a little bit earlier when we were doing the that warm-up question with the independent variable and dependent variable. And we look at a chart to determine, or a table to determine whether it's linear or non-linear. Like Will said, it's going to follow a pattern. We're going to talk about that in a second. Yo, what's up?
We missed, like, if it's a linear function.
Oh, we're going to get there. It's going to be in the bottom of this.
Oh.
We want to talk about this one first, and then we'll build that in. Thank you for reminding me. All right? So we're going to practice identifying linear functions by looking at a table. So this is example 2, question A. All right. So what's happening to the x value every time? From here, from the 3 to the 6, from the 3 to the 6, the 6 to the 9, the 9 to the 12. What's happening, Will? It's adding by 3 every time. So plus 3, plus 3, plus 3. It's constant, right? It's the same number. That's okay. All right. Now, the y values, we go from 36 to 30, to 24 to 18. Like Noah just said, we're minusing 6 every time. Now, like the question asks, do we notice any patterns?
Yes.
We do. What's the pattern? What's one pattern we notice, Will?
Plus 3 of the x.
The x's are increasing by 3 each time, or consistently. Mr. Hager's right. How about the y's? Jack, what about the y's?
The y's are subtracting with 6.
Yeah, or decreasing, right? So the y's are decreasing consistently each time, all right? So there's our pattern, right? The x's are increasing by 3, and the y's are decreasing by 6, all right? So, so here's the thing. Here's the question you guys were. Here's the note. Here's a part of your notes. It is a linear function if the x goes up consistently by adding the same number. We had that in our example, right? The x was increasing by 3 each time. Right? The x was increasing by 3 each time. Y also changes at a constant rate, either using addition or subtraction. Here, so the big thing with this is the x has to increase. The x cannot decrease, the x has to increase. So don't get confused if you have like -6, -3, 0, 3. Say these are our x's, right? What's happening to those x values? Even though we started with a negative, what's happening? Sophia, do you see the pattern? If you're not sure, look at the positive numbers. Look at from 0 to 3, what's happening?
It's going up.
By how much? 3. Plus 3. Same thing's happening here. Plus 3. Negative 3 plus 3 is 0. Same thing's happening here. I'm adding 3. Negative 6 plus 3 is negative 3. So you could have a situation where you're starting with negatives. It's okay. As long as the x's are increasing, you're all right. The y's, they could either be increasing, so you could be adding the y's, or you could be subtracting the y's. Remember, increasing only works for the x's have to increase. The y's can either decrease or increase. It doesn't matter. All right? Now remember, just because it shows an arrow, let's go back into our example. The x and the y don't have to increase by the same number. Just because our x increased by 3 doesn't mean our y's have to increase by 3. Our y's can increase or decrease by a different number. So they don't have to increase or decrease by the same number that the x's did. Right, so let's understand that. That covers that. Everybody's got this copy down, the linear function thing. So now just like we did before with identifying whether it's a function or not, that meant we can't have anything repeating. We gave you like the input and the output. Now we're going to see whether it's a special kind of function, a linear function, based on a chart. And again, we got to see if it increased, the x's have to increase by the same thing, the y's have to increase or decrease by the same thing, or a constant. So let's look at example B. Someone tell me by raising their hand. Are you guys going to write this in too? It's okay. Madison, what's happening with the x's?
They're going up by 2.
Okay, so that covers one part, right? The x's are all increasing by the same thing, right? At plus 2. Remember, the x's have to increase. They can't decrease. They have to increase for it to be linear. So if this is like minus 2, it'd be a nonlinear function right off the bat because it's decreasing. They have to increase. Okay. From Mallory, from 2 to 7, how much? How much am I increasing by?
7.
7. Alright, now, x, from 9 to 20, how much am I increasing? Nope. Joe? Plus 11. Do I need to go any further? Do I need to go any further than that, Fred? No, why? Yeah, it's increasing by a different number. So what does that mean about this function?
It's not.
It's not a function, or it's going to be non-linear. I'm not asking whether it's a function or not. I'm asking if it's a specific kind of function, linear or non-linear. In this case, it's non-linear. Now we had one part of it be we had half of it, right? How do we have half of it? We had half but almost 2. Why do we have half but almost 2, Mallory?
Because the y wasn't constant.
Yeah, we had half because the y's weren't increasing or decreasing by the same thing, but the x's were, right? Mr. Hager is going to show you what it looks like. If you use like his graphing calculator, he's going to show you what it looks like.
Can we use them in class this year?
I think we do something a little bit later in the year. Let you guys do.
Silly rabbit tricks for kids.
So that's what it looks like, right? If I was to connect those dots, again, I get a wavy line, right? So that's no good. So Mr. Hager wanted to show you guys what it looked like if you were to graph it. So it does prove itself true because it's not a straight line. For it to be linear, it has to be a straight line. All right, let's look at C. Fred, what are the x's increasing by? 1, very good. Consistently, right? Plus 1, plus 1, plus 1. From here to here is plus 1, from there to there, from there to there. Or plus 1 every time. Alright? Jack, what about the Y's?
By 2.
By 2, right? The Y's are increasing by 2 every time. So, Connor, what does that mean? If the X's are increasing by the same number and the Y's are increasing or decreasing by the same number. What does that mean?
It's linear.
It's linear. Very good. It's a linear function. So C will be linear. And like I said, remember, just because the X's are increasing by 1 doesn't mean the Y's have to increase by 1. They can increase or decrease by a different number. Doesn't have to be the same for the X for the Y. And then Mr. Hager just showed you guys, that's what it looks like. We punched it in his graphing calculator, you get a straight line, so that this proves that it is linear. That it's a linear function. All right, we got D left.
What was A? Was it linear?
A was, I
Yes.
believe, linear. Yep, the example was linear. All right, so, Connor, for D, right? What are the X's? What's happening to them?
They're going up by 1.
Going up by 1 every time, right? Plus 1, plus 1, plus 1 each time. Okay. Can anybody tell me by raising their hand what's happening to the Y's? Will?
They're going down by 4.
They're going down by 4. So 16 minus 4 is 8.
Oh, my bad.
It got you. Again, here it did. Here I minus 4. From 4 to 2, what happened? Minus 2. And then from 16 to 8, what did I do, Sydney? Minus 8. Is it the same? No, it's not the same number. It's kind of like a pattern, right? They're all like even numbers, but again, we need to be subtracting or adding by the same number. What's that mean, Noah? What does that mean about that function? It's either going to be what or what? Non-linear, right? It's not consistent. Yes, the X's are, but the Y's are not. So non-linear. And again, is that it right there, Mr. Hager?
I just freehanded.
Okay. It was kind of something like that, but again, as long as you know if it's not a straight line, it's not a function. Right, so that's another way we could look at it. One way we looked at it so far is look at a graph. So if I'm looking at a graph, how do I know if it's a function or not? Someone tell me by raising their hand. How do I know if it's a function or not looking at a graph? Somebody besides Joe. Valerie?
It's maybe not a straight line, but you get the graph.
If you get the graph, if it's not a straight line, what does that mean?
It's not.
Non-linear. If it's a straight line, linear. Very good. That's one way we'll look at it. Here, we'll look at it based on a chart. Right? When I look at that chart, we're going to make sure that the X's are increasing by the same thing, and the Y's are either increasing or decreasing by the same thing. That's another way we'll ask you to identify linear or non-linear. Alright? One more way. Alright? Alright. So remember, anything that's a linear function is going to be written in this form. Y equals mx plus b. You have to have a y, you have to have an x, then you might have just another number, but you could just have y and x. That's okay. So the third way we're going to ask you guys to identify whether it's linear or non-linear is based on an equation. We're going to give you an equation, we're going to ask you to look at it and tell us whether it's linear or non-linear. So 3 different ways we talked about today. If something's linear or non-linear. 3 different ways we'll ask you. Based on a graph, based on a chart, and based on an equation. It's a regular equation. Alright? It's really not that hard. Guys, don't panic. You don't have to solve any equations here. You don't have to solve anything. We're just going to give you some hints to say, if you see something like this there, that tells you that it's linear. If you see something like this, it's non-linear. Alright? So, if you have any of these following things, first thing, if you have a square root, alright, with a variable, something like y equals the square root of a, So we'll go through the list, then we'll talk about at the end whether it's gonna be linear or non-linear. So if you have something with, like, if you have square roots with variables, say your example is like y equals the square root of a.
Next.
All right, next. Variables in the bottom of a fraction. Say you had y equals 2 over x. So that example, since it's kind of cut off a little bit, it does say y equals 2 over x.
I do like stuff.
If you have variables as exponents, so like y equals 4 to the x, you don't want that.
What is the second one? 2 over x?
2 over x, yep, y equals 2 over x. If you have variables as exponents, like y equals 4 to the power of x, you don't want that. All right? Y equals 4 to the power of x.
I'm cool too.
No.
Alright, variables with exponents other than 1. So if you have something, I mean, every number that we write is to the first power, we just don't write to the first power every time, it's assumed. Just like if we have the number 2 written like this, we assume that it's positive. It's just the way it is. We don't write positive 2 every time. Just like every number, like that 3 is to the first power, we just don't write it. So if you have variables with exponents other than 1, so if you see something in the problem to the 3rd power, to the 4th power, to the 25th power, to the 2nd power, that's going to make any one of these situations, all right, any one of these 1, 2, 3, 4 things that we talk about. Also, if you have, let's check it, absolute value would also be nonlinear, correct? If you had absolute value, like the bars, absolute value. Like if you had absolute value bars, that's also going to make it. Every one of these things are not functions. They're all going to be non-linear. Any one of these things any one of these things show up in one of the equations that we give you, it's going to make it non-linear. You don't have to solve it. You don't have to do any math. You just have to look for one of these things. If it has one of those things, it's non-linear. If it's like a nice equation like y equals 2x plus 5, that's going to be linear, because I say if you look at the equation and it has funky stuff going on, like stuff that kind of looks weird, that means that's bad. That means it's not linear. If it has just regular old a y, an x, and a couple numbers, you're good. That means it's going to be linear. All right? So those are not going to be linear functions. Everybody good with the list?
Yeah.
Okay. So let's look at some examples.
Huh?
So example 3, last thing we're going to do today in terms of notes. All right? So you guys, let's go through it. I'll scroll up.
Wait, what's A?
You want to cover it, story?
No, not the cover. We'll write them all down. They can write them all down first.
I can't.
We'll go.
Oof, I can't see.
Hold on.
Give him a second, please.
So I'll give you guys a minute or so to get those copied down, and then we'll go through and determine whether they're linear or non-linear based on the notes that we just took. So A. Someone tell me by raising their hand. Is that going to be linear or is that going to be non-linear? X?
Non-linear? No, linear.
Linear, right? Even though it's got a decimal, there's no exponents there. There's no square roots there. None of that stuff is there. We're okay. So that's going to be.
Think of this as 0. Oh, no, I get it.
Yeah. Even though the x is not there, that's okay. It'll still work. So think of this as 0x plus 3.8. So if you had y equals something, it's okay. If you had y equals just a number, that's okay. It'll still be a function. All right. Look at B. Y equals the square root of x. Josiah?
Non-linear.
Non-linear, right? We talked about that in our notes, right? If it has a variable, as a square root, we can't have that. That's funky. We don't want that. So this is going to be B will be non-linear. All right? Jack, what about B?
You just did B.
C, I'm sorry. How about C? C going to be linear or non-linear?
Non-linear.
Non-linear Y.
Exponent.
Yeah, it's got a variable as the exponent. So that's going to be C is going to be a non-linear function. All right? Let's scroll down to D. Oops. Let's go down.
No.
Sorry, Steve. D says y equals 2 over x. Nathan, what do you think? Is that going to be linear or non-linear? No. Non-linear, right? Remember, we said we can't have a variable as the bottom part of a fraction. If it was y equals x over 2, that'd be okay, because right, the variable would be the top part of the fraction. We don't want the variable as the bottom part. All right, now E is a tricky one. How many people say that E is going to be non-linear? Raise your hand if it's going to be non-linear. How many people think it's going to be linear? Yeah, don't get confused. Don't get confused by the parentheses. What do the parentheses mean? What do you have to do?
Multiplication.
Multiplication, right? When I multiply, y equals, right? What's 6 times x?
6x.
6x. And then positive 6 times a negative 1? Negative 6. I end up with an x and a y with no funky stuff.
Yeah.
Right? No exponents, no square roots, none of that stuff. So be careful. There it is. This equation is in that format. It's in the linear function format. That's what I want. So again, just because it had parentheses doesn't always mean that it's not going to be linear. Double check it. Distribute it out. Now, if this was like negative 1x, that would give me, actually, let's say if there was something else on the, like if there was not, like say if this was like x to the second power, that would make it non-linear because you have an exponent greater than 1. So just pay attention when you have parentheses. Just pay attention to what's on the inside.
Wait, so if I have an exponent, does it mean it's non-linear?
Yes.
Just any exponent? Or is
Yeah, basically, it's going to be any exponent greater than 1. But if we give you an exponent, no, it's going to be greater than 1.
Okay.
All right?
And wherever it has the square.
Yeah, square root, anything like that, absolute value, that means it's all going to be non-linear. All right? Now we get x to the second minus y equals 0. Connor, what do you think? Linear or non-linear?
Non-linear.
Why? What makes you say that it's non-linear?
I don't know.
There had to be something there that told you it was going to be non-linear.
The 2 over x.
Yeah, the little exponent thing, right? It's weird, right? It's anything that's funky, that's going to make it non-linear. All right? Next one, G. We have y equals x plus 9. What do you think, Paige?
Linear.
Linear, I agree. There's nothing funky going on there. There's no exponents. There's no variables as exponents. It looks nice, it looks neat. That's what I want. Y equals 3x over 5. X.
Non-linear?
Huh?
Non-linear?
Madison?
I was thinking linear variable in the variable.
Exactly. Like Madison just said. Like Madison just said. She said that the variable is on the top, not on the
That's what
bottom.
messed me up.
Alright? If it's in the middle like that, that's still gonna be okay. That's still gonna be linear. We then, because this number with x, when we start talking about it in chapter 4, that's gonna be the slope. It's okay if slope is a fraction, because it's rise over run. So, we talked about 3 ways that you can determine whether a function is linear or non-linear. Someone tell me one way. Mallory.
Graph.
Graph, right? Explain more. How do I know if it's linear or non-linear?
Like if the line's not straight, then it's like
If
non-linear.
the line's not straight, it's non-linear. If the line's straight, it's linear. Good. What's another way we talk about determining whether it's linear or non-linear? X.
Equations.
Equations, right? What are you looking for in those equations?
Exponents.
exponents, funky stuff, right? If it's just a nice, neat equation, it's gonna be linear. So we'll look at equations, we'll look at a graph, one more way. What was the other way we looked at to say whether it was linear or non-linear? Josiah?
Tables.
The table, right? Can you explain to me how that works?
If the table number repeats in the first one, then it's another.
That's to determine if it's a function or not a function. Now we've gone a little bit deeper.
Oh,
I wanna know if it's linear or non-linear.
if there's no pattern.
If there's no pattern, that means it's non-linear. Is that true? How you said that, Josiah? If there's no pattern, non-linear. Pattern, linear.
We
All
want
right?
to use these notes on the test.
No. But if you want to copy them down, copy some of the notes down onto your, like there'll be a question on your reference sheet tomorrow night that talks about like linear, non-linear from a equation. If you want to copy those things down, you can. And you guys just don't have to put like, if you want to put more than what's on your reference sheet, if you want to do more than just answer the questions that are on your reference sheet, you can do that. You can put more on there. Any notes we put during the week, you want to put them on your reference sheet, that's fine. Right, you can copy it down. If we only have a single-sided reference sheet, you want to write something on the back, that's fine too. All right? So, like I said at the beginning of the lesson, tomorrow's the last day for new stuff for this week. We'll do the second part of 3.2 tomorrow. All right? Reference sheet tomorrow night for homework. We'll try to get that up a little bit earlier in the day. I know that worked out well for people last academic week when we did that. We'll try to do that again this week. Remember, test on Thursday because we have no school on Friday. So the test will be Thursday
We should have a conference.
because we have no school on Friday. All
I'll be
right?
after school tomorrow, first thing.
Yeah, I'll be active for a little bit as well too if people need to stay.